Welcome to the Deep Dive. Today, we're really getting into the weeds on semiconductors. It's this incredibly high-stakes world. And these tiny chips, right, they're basically the hidden engines driving, well, almost everything modern. AI, cars, you name it. So we're unpacking July 2025. It was quite a month. Some really, really pivotal things happened in the semiconductor industry. And this deep dive should get you right up to speed on, what really matters.
It's definitely more than just silicon these days, isn't it? What's really remarkable, I think, is how tangled up it all is. You've got global strategy, these massive multi-billion-dollar deals, the tech race for the next node.
That never stops.
Exactly.
Yeah.
And then the whole geopolitical layer shaping the chip ecosystem. It's moving so fast.
Yeah.
And these changes, they're foundational, really foundational.
Yeah, absolutely. So our goal here for you listening is to give you a solid grasp of these key moments. We want to pull out some surprising bits, help you connect the dots on things that might seem separate, but ultimately shape the tech you use constantly. So let's kick off with maybe the biggest headline.
Sounds good.
Samsung's huge deal with Tesla. We're talking $16.5 billion.
Wow.
And it's not just, generic chips. It's specifically for their next-gen automotive AI chips, the AI-6. And this locks them in together through 2033.
That's a long commitment in this space.
It really is. And the production, it's happening at Samsung's fab in Taylor, Texas.
Right, which is super close to Tesla's Austin HQ.
Exactly. Not an accident. Clearly signals they want deep collaboration, hands-on engineering.
Yeah, and what's really fascinating here, I think, is Elon Musk getting personally involved, apparently co-developing the actual design for manufacturing workflows. That tells you a lot.
What does it signal, do you think?
Well, it strongly suggests Tesla's making a big pivot, moving away from trying to do all the chip production in-house. Instead, they're leveraging Samsung's really advanced foundry capabilities. It's smart outsourcing, really.
Makes sense. And the market reacted immediately. Samsung stock shot up 6.8%.
Non-surprising.
But here's the interesting part. Intel's stock actually dropped.
Oh, why is that?
Well, reports came out that Tesla specifically excluded Intel from even bidding on this.
Ouch.
Yeah. Really throws the intense competition in this sector into sharp relief, doesn't it? High stakes.
Absolutely.
Okay, so speaking of Intel, that brings us neatly to the other side of the coin, right? Their big global retrenchment.
Yeah, that was significant news, too.
And this is where it gets, well, pretty dramatic. Intel announced massive layoffs. We're talking about 24,000 employees.
That's huge, about 15% of their total workforce.
15%. And it came alongside canceling those huge multi-billion-dollar fab projects, the one in Magdeburg, Germany.
And Wrocław in Poland? Gone.
Plus, reports are they're scaling back advanced node work at their Oregon fab as well.
Right. These actions, they definitely point towards major strategic rethink at Intel. And you also had the spinoff of RealSense. That's their robotics and vision AI division.
Yeah.
Now it's independent.
So how are analysts reading all this?
Well, the general view seems to be it's more than just cutting costs. It's
Sure.
seen as a strategic refocus. Some think maybe they're pulling back from competing head-to-head on the absolute bleeding-edge logic foundry stuff. Maybe doubling down on their own products with IDM 2.0 or focusing foundry services on specific niches, perhaps.
It definitely raises questions about what Intel's core focus, their identity will be going forward.
Exactly. It's a big shift to watch.
Okay, so while some are pulling back, the race at the absolute cutting edge, the tech frontier, is just getting faster. Let's talk about the 2-nanometer process node, that global push.
Yeah, the next big leap.
The key players everyone's watching, TSMC, Samsung, and Japan's Rapidus.
Right.
TSMC seems to be, well, leading the charge, already starting to ramp up 2-nanometer production for big clients like Apple, Nvidia.
Using the nanosheet gate all-around transistors, the GAA tech.
That's the one. And Samsung, they're right there too, moving ahead with their SF2, their 2-nanometer roadmap.
And they're using their own version, MBC FET structures.
Yeah.
Multi-bridge channel FETs.
Interesting. And then there's Rapidus, the Japanese consortium.
They had a big milestone in July. Delivered their first 2-nanometer prototype wafers.
Prototypes, okay. But still significant.
Very. They have a super ambitious goal for volume production by 2027.
Wow. So zooming out, like you said, all three are betting heavily on this GAA transistor architecture.
It's critical. It's seen as the way to get past the limits of the older FinFET technology as things get smaller and smaller.
And why does this matter so much for, the average person?
Well, this kind of technical leap is what pushes the boundaries of what our devices can actually do. It means more power, better efficiency, basically enabling the next wave of tech.
Got it. More powerful, more efficient stuff.
Exactly.
Okay, let's shift gears slightly. It's not just the transistors, right? Memory and packaging are becoming increasingly vital.
Oh, absolute critical. Often overlooked, but hugely important now.
So, big news on the memory front. JEDEC officially released the LPDDR6 standard.
Finally, yeah, that's aimed squarely at next-gen stuff. AI, AR, VR, high-end phones.
Needs that faster memory. And speaking of critical pieces, Samsung's investing heavily in packaging. A massive $7 billion for a new advanced packaging plant in the U.S.
$7 billion just on packaging. That tells you something.
Right, focusing on 2.5D, 3D stacking, hybrid bonding, all that advanced stuff.
And this fits the broader trend. The whole industry is putting way more emphasis on high-bandwidth memory, HBM and chiplets, interposer systems, basically stacking and connecting chips in smarter ways.
So why the sudden focus?
Well, here's the stat that blows my mind. Packaging now accounts for something like 30% of a final chip's performance and cost.
30%, just the packaging.
Yep. It's not just a box anymore. It is critical to how well the chip works as the silicon itself.
Wow, so better integration there means
Faster, more powerful devices for you. And potentially more energy efficient, too. It all connects.
Okay, let's broaden it out again. Look at the strategic landscape. Because it's not just tech R&D, there are big corporate moves happening.
Always.
First, Synopsys finally closed that huge $35 billion deal to buy Ansys.
Colossal deal. Merging EDA, the chip design tools, with ANSY's simulation power.
What's the goal there?
Really, to better serve these super demanding areas like AI, high-performance computing, complex automotive designs. They need both sides tightly integrated.
Makes sense. Then you had Nvidia making a pretty significant announcement, CUDA runtime compatibility for RISC-V.
Oh, interesting. That's a big deal for opening up the AI accelerator space, right? Using NVIDIA's software platform on non-NVIDIA open source hardware architecture.
Exactly. Opens doors for developers. And another move, GlobalFoundries bought MIP's architecture IP.
Right, aiming to beef up their offerings for low-power AI chips, those system-on-chips or SoCs.
So if you tie all these together, Synopsys senses, NVIDIA RSCV, LoFo MIPS, what's the bigger picture?
I think the overarching trend is clear. You're seeing this push towards both vertical integration, like the Synopsys deal, and the rise of more open ecosystems like RISC-V. It's fundamentally changing how chips are developed, creating new ways to innovate, new collaborations.
Fascinating. Okay, we can't have this conversation without talking geopolitics. It's just unavoidable in semiconductors now.
Absolutely central.
So July saw the U.S. and the EU sign a trade agreement.
Yeah.
A big one. Eliminating tariffs on semiconductor manufacturing equipment.
Yeah, that's huge for the big tool makers. ASML.
Applied Materials, Lam Research, Tokyo Electron, all the key players benefit. Should lower costs, ease trade flow there.
Definitely.
But on the flip side, the U.S. also expanded its AI chip export controls.
Right. Adding Thailand and Malaysia to the list of countries facing restrictions, broadening that net.
So how is China reacting to these tighter controls?
Well, the report suggests they're hitting the accelerator on their domestic efforts, particularly for EUV, the extreme ultraviolet lithography needed for advanced nodes, and just lithography tools in general, trying to become more self-sufficient.
Which just fuels this ongoing tech race, doesn't it? With massive global implications for supply chains, who innovates where?
Exactly. It raises really important questions about the future. And just to be clear, we're simply reporting what the sources indicate here, laying out the different facets of this complex global dynamic.
Right. Important context. Okay, let's wrap up with a snapshot of the market. Where did things stand in Q2 2025? Foundry rankings.
Okay, well, no surprise at the top. TSMC continues to dominate the global foundry market. Their share was around 67.6%.
67.6%. Still way out front.
Way out front. Samsung followed, holding about 7.7% market share.
Okay. And Rapidus, Intel.
Both still below 2% in the foundry space. Shows that massive gap, especially at those leading-edge nodes TSMC commands.
And one specific supplier note? Google confirmed they're using TSMC for the upcoming Pixel 10, for the Tensor G5 chip.
Yep, another big win for TSMC.
But there is some positive news overall for the market.
Yeah, good indicator. The Semiconductor Industry Association, the SIA, reported 3.5% month-over-month growth in global chip sales.
Okay, so some healthy growth there.
A positive sign for the industry's overall health. So what does all this mean for the industry's direction and for you listening? These market shares, these investments, the growth trends, they directly influence the cost and availability of pretty much all the tech you depend on. Phones, cars, cloud services, everything.
Right. It all trickles down.
So looking back at July 2025, It really underscores the incredible speed and dynamism of the semiconductor world. You
Right.
had these huge deals, major companies rethinking strategy, that intense 2-nanometer race-pushing physics, and global politics constantly reshaping the playing field. These aren't just, niche technical updates. They are fundamental drivers shaping our technological future.
Absolutely. And like we've said, these big shifts, they directly land in your everyday life. They affect the power, the battery life, the cool new features in your next phone, your car safety systems, the AI you chat with. It's all connected back to this. So what does this all mean for you to think about? Beyond just the step dive today, well, here's something to chew on. Given this fierce 2-millimeter competition, this rising importance of packaging as a way to differentiate performance, and these really complex geopolitical tensions squeezing supply chains, what does the next year actually hold? Will we see even more companies emerging? Maybe some surprising new alliances form? Or could total disruptive innovations pop up from all this pressure, changing the game all over again?